No dumb questions.
Welcome to another segment of No Dumb Questions, where the only dumb question is the question you don't ask. Today's question is, what is skew and how is it minimized? So what is skew and how do we define it? Skew is the difference in time it takes for two signals to arrive to the destination. A good analogy of this would be, if we had a 10-foot table and we had car A and car A driving straight down the table and car B swerving, what would the difference in time be of their arrival? If car A beat car B by 10 seconds, this skew would be 10 seconds per 10 feet, or 1 second per foot. Why is minimized skew important? When communicating at fast data rates, expressed in gigabytes per second, minimized skew is crucial to getting a quality signal. I'm going to go over the three reasons that are most commonly causing skew in electrical wire. Reason number one, there's a difference in velocity of propagation, or VOP. To learn more about what VOP is, see the link below. So, for example, differences in the dielectric material that may cause that are, we could use two different materials. We could use a FEP and a PVC. The FEP is with a higher velocity of propagation, where the PVC has a lower velocity of propagation. Therefore, the electrical wire insulated with the FEP dielectric will transmit faster than the electrical wire insulated with the PVC dielectric. Therefore, the FEP signal will arrive sooner than the PVC signal. Reason number two, you may have unbalanced tension twisting two wires together, leading to an effect called Barber pulling, where one wire takes a straight parallel path and the other wire takes a long orbital path. Here's an example of that. This is two wires twisted together. However, when we untwist them and compare the total length, we can see that one wire is much longer than the other. Therefore, it's taking a longer path to the destination. Reason number three why you might have electrical skew. You may have mismatched diameters that you are twisting together. This is an exaggerated example, but if we had cable A and cable B with a much larger diameter and we twisted them together, the circumference that the larger cable would have to twist around is much smaller than the circumference that the smaller wire has to be twisted around. Therefore, it's going to take a more orbital path, the smaller wire, versus the large wire, which is going to be in more of a parallel path. So in summary, how do we minimize electrical skew? First, we ensure that the dielectric materials are equal. They have equal velocity of propagations and that we're not diluting them with colorants, for instance, to unbalance those. Second, we ensure that we use equal tension so that we can mechanically balance a twisted pair and ensure that the mechanical length of two legs of a twisted pair are equal in length. And finally, we ensure that both legs of a twisted pair are equal in diameter. Therefore, we can eliminate the Barber pulling. So I hope I helped answer that question today of what is skew and how do we minimize it. For any additional questions, reach out to New England Wire and don't let skew up your signals. And that concludes today's segment of No Dumb Questions.